and welcome back to science class. Today, we are going to talk about the combustion of fossil fuels, and we're going to look at how to balance combustion reactions. So as we know, we represent chemical reactions through the use of chemical equations. Now, there is a basic formula that we use for combustion reactions. We have the reactants, which are the fuel and the oxygen, and they combine to form the exhaust. In this case, the products is called the exhaust. Now, this reaction also releases heat. Combustion is an exothermic reaction. Exothermic means it releases heat. Here is an example of a combustion reaction. Here we have methane reacting with oxygen to give us carbon dioxide, water vapor, and heat. So these are the products here. This is the exhaust, this is the fuel, and this is the oxygen. Now, this is an unbalanced formula, and we're going to try to balance it ourselves. So the first thing we're going to do is we're going to draw a table, and we're going to start counting the atoms on each side. So we have carbon, we have hydrogen, and we have oxygen on each side. If we take a look on this side here, we have one carbon atom, and we have 4 hydrogens. Then we have 2 oxygens right there. On this side right here, we have 1 carbon. So far, so good. We have 2 hydrogens. Oh, we can see that there's already disparity there. And we have 1, 2, 3 oxygens. So, I'm going to want to balance the hydrogens first. So I'm going to take a look at the side where I have the least amount of hydrogens. In this case, the product side. I'm going to add a coefficient in front of my H2O to increase the number of hydrogens I have. I'm going to put a number 2 right there. Now, I'm going to go ahead and count all of my atoms on the product side. So I still have 1 carbon. I now have 4 hydrogen. And I also have 1, 2, 3, 4 oxygen. So I have 4 in total. Now, I need to balance out my oxygens because you see I have only 2 on this side and I have 4 on this side. So I'm going to go to my reactant side and I'm going to put a coefficient in front of my oxygen. I'm going to put the number 2 there. Now that I've put the 2 there, I'm going to count all the atoms on this side once again. I have 1 carbon, 4 hydrogen, and now I have 2 of these oxygen molecules, which have 2 oxygen atoms, which means I have 4 oxygen atoms in total. And now we are balanced. So we know that a combustion reaction often gives us carbon dioxide and water. Those are not the only products that you can make in a combustion reaction, but for the most part, those are pretty common. Now, when we burn fossil fuels, it's the same thing. We have carbon dioxide that's emitted, which we know is a greenhouse gas, which causes climate change and global warming, and it also releases water. Now, that is a perfect scenario. That's assuming that the fossil fuel, the coal, the gas, and the oil are 100% pure. In most cases, this doesn't happen. There's often contaminants inside these substances. So the combustion reaction isn't necessarily a perfect scenario. And this means that we're going to have other byproducts that appear and are emitted. Some of these byproducts are carbon monoxide and ash or soot. Carbon monoxide is an incredibly poisonous gas for animals and humans. That's because when we breathe it in, it actually displaces the oxygen in our lungs. Therefore, it depletes our body from oxygen, and we basically suffocate. Carbon monoxide is most dangerous in enclosed spaces that have little to no ventilation. So think a car garage. You don't want to be running your car in a closed environment because the combustion of that actually gives off a little bit of carbon monoxide. And over time, the entire space of the garage will fill up with carbon monoxide, thus poisoning whoever might be in the garage at the time. So you always want to make sure that you run combustion in open air, because you never know if it's pure or impure. Now, ash and soot is not necessarily bad for the environment. However, if we were to inhale it, it can cause damage to our lungs. Think of like smoking. We know that smoking damages our lungs, and that's because of the particulate matter in the smoke. The particulate matter is not supposed to go into our lungs, and so when it goes in, our lungs fight it off, and it creates scar tissue, which then causes other problems down the road, like lung cancer and other lung diseases. Now, when big coal plants burn coal, there's a bunch of soot that gets released, and it often happens through these chimneys, these smokestacks. Now, what happens is that the wind catches this soot in the air and transports it all over the world. Now, most of it will land in the ocean and on the land, which is not a problem. However, if it lands on snowy places like the Arctic or the Antarctic, then it becomes a bit of a problem. You see, the soot is a dark color. The soot will absorb more of the sun's energy. Snow tends to reflect the sun's energy, but soot will absorb it. Now, the soot on the snow will become warm, and then it melts the snow around it. So the transportation of soot to the North and South poles actually increase the chances of snow melting, and it increases the speed of the ice and glaciers melting. So that's another way burning fossil fuels affects climate change and the melting of the Arctic. Thank you for listening, and I will see you guys next time. Bye!